Today we are on page 5 of our Chapter 2 notes packet, page 5. Continuing where we left off the other day, we're adding and subtracting rational expressions with unlike denominators. So starting on page 5, number 5, we have these two rational expressions, a squared over a minus b plus b squared over b minus a. Now, whenever we want to add rational expressions, we need the same denominator. Well, as they are, these denominators are not like, but you should recognize them as being opposites. So, if I like the looks of a minus b, so if I take our second denominator, and if I factor out a negative 1, what if I just factor out a negative 1 here? The negative 1 times negative b would bring me to b, and negative 1 times a would result in negative a. So I factor out negative 1, and I have negative b plus a. Well, this is the same as a minus b. Right? Let me just rewrite this with the a first. This would be a positive a, and now minus b. So now these denominators are the same as long as I take the negative 1, and why not just bring it up into the numerator? All right? So we have a squared over a minus b plus negative b squared over a minus b. Same denominators, copy the denominator, a minus b, and now combine a squared plus negative b squared is a squared minus b squared. Now that we have our single fraction, can it be simplified? Yes. This is dots. So this is a plus b times a minus b over a minus b. And the a minus b's divide out. And finally we arrive at our answer of a plus b over 1, which is simply a plus b. Next, number 6. Now it said back on page 4 of the notes that sometimes you want to factor your denominators, and that's what we want to do here. All right, I'll take the second denominator. There's a GCF of x. Factor that out. Now take the larger one. This appears to be larger. Does x minus 2 divide evenly into it? Yes. So that is our least common denominator. So we are writing down equivalent fractions with a denominator of x times x minus 2. What do we multiply x minus 2 by to get x times x minus 2? We need to multiply it by x, so do the same to the numerator. So that's going to be x squared plus 3x. This is already our denominator, so just bring down the numerator of 10. Same denominators. Let's copy that first. And now x squared plus 3x subtract 10. There are no like terms there, so we just write it as a trinomial. We have our single rational expression. Now see, can it be simplified? Well, our numerator, the trinomial, are there factors of negative 10 that add to positive 3? Yes, 5 and negative 2. So this factors into x plus 5 times x minus 2 over x times x minus 2. And the x minus 2's divide out. So our answer is x plus 5 over x. Number 7. Again, I'm going to factor the denominator. This is the difference of two perfect squares, x plus 6 times x minus 6. Here, GCF x, other factor x plus 6. Both are rather complicated. Okay, so we need each factor the greatest number of times it appears in any denominator. All right, meaning they both have an x plus 6, so we need that for a common denominator. This has an x minus 1. We'll need an x minus 1. That takes care of this denominator, but this one has an x, so we also need an x. Just going to write the x first in our second denominator. Okay, what do we multiply this by to get this? X. So we do the same to the numerator, so x times 2 is 2x. And what's missing here to arrive at this? X minus 6. 1 times x minus 6 is x minus 6. Same denominator. Let's bring that over, copy it. X times x plus 6 times x minus 6. And again, now combining like terms, bold out this subtraction, right? You're doing 2x minus x, which is 1x. And minus a negative 6 is plus 6. So we have our single rational expression. Can it be simplified? Yes, the x plus 6 is divide out. So we have a final answer of 1 over x times x minus 6. And it's perfectly fine to leave it in factored form. You do not have to distribute the x over the parentheses. Number 8, again, look at these two denominators. We'll factor them. Difference of two squares, x plus 7 times x minus 7. The trinomial, factors of negative 35 that add to negative 2 are negative 7 and 5, so x minus 7 times x plus 5. We're writing down equivalent fractions with the same denominator. Okay, well, what is the same denominator? What's our least common denominator here? X plus 7, this one doesn't have one, but we need it. X minus 7, they both have, so we need one x minus 7. And x plus 5. Again, it's each factor the greatest number of times it occurs in any denominator. All right, what's missing here to arrive at this? The x plus 5. So we multiply by x plus 5, both numerator and denominator. 7 times x plus 5, make sure you distribute, that's 7x plus 35. What's missing here is the x plus 7, so we multiply by x plus 7. Again, make sure you distribute. 6 times x plus 7, 6x plus 42. Okay, we have our equivalent denominator, we have our equivalent fractions with the same denominator. So let's copy that. And now combining like terms of the numerator. Again, subtraction, so be very careful. 7x subtract 6x is x. 35 subtract 42 is negative 7. Our single rational expression, can it simplify? Yes, the x minus 7's divide out. So our final answer is 1 over x plus 7 times x minus, times x plus 5. All right, and one more for today. And look at these denominators. Our third denominator here is factorable. That's dots. This is a difference of two squares, 2x and 1, right? So this factors into 2x plus 1 times 2x minus 1. Now we're writing down equivalent fractions with the same least common denominator. What is that least common denominator? It is 2x plus 1 times 2x minus 1. Don't be lazy here. Make sure you're writing all of this down. All right, for our first rational expression, we need to multiply by 2x plus 1, the denominator. So do the same to the numerator and distribute, so that's 4x plus 2. Our second expression, we need to multiply by 2x minus 1. Again, same to the numerator. 2x minus 1. And our third one already has that as a denominator, so bring down the numerator of 2. Copy our denominator. 2x plus 1 times 2x minus 1. Now combining. Again, watch these subtractions. Be very careful. This is 4x, subtract 2x, will be 2x, because there is no other x term that follows. And now 2 subtract negative 1 would be 2 plus 1, which is 3. And 3 subtract 2 is 1, positive 1. Now, can this fraction reduce? Yes, the 2x plus 1's divide out. So our answer is 1 over 2x minus 1. And this concludes tonight's video.